Changes in the process location and the spread can lead to out-of-specification products. In this lesson, you will learn how to create a median chart and a range chart. And hello again to this lesson, which essentially has 3 learning objectives. But before we get to that, a short foreword. There are already separate lessons for creating a median chart and a range chart. So, how's this lesson different? In the separate lessons for the median and range chart, the warning and control limits were calculated for a non-interference probability of 95 and 99% respectively. In this lesson, only the control limits for a non-interference probability of 99.97% are calculated. This corresponds to a limit width of 6 sigma, so plus minus 3 times the standard deviation. Depending on the region or the respective country or various specifications, both the 99 and the 99.97% limits are used. Therefore, in this lesson, the focus will be on the 6 sigma limits, and this in combination with monitoring the process location with the mean chart and the spread with the range chart. For those who haven't seen the other lessons, the most important basics are briefly repeated again. So, after this lesson, you should know the basics of a median chart and a range chart. Furthermore, you should be able to determine the process center line of the median chart and that of the range chart based on the data from a pre-series. And almost most importantly, of course, you should be able to calculate the control limits for both control charts. This lesson is divided into 3 chapters. In the first chapter, we get an overview of the basics of the median chart and the range chart. In the second chapter, the process center lines of these 2 charts are determined based on a random sample. And in the last chapter, the control limits are then calculated. So, let's start with a quick review of the basics of the median chart and range chart. We take again the diameter of a piston as an example. Its diameter of 60.1 mm is the product characteristic that is to be monitored with the control charts. When we talk about the median, then for us, this is one of the location parameters that can be used to describe the process center line. The median is the value separating the higher half from the lower half of a set of data. There is also the arithmetic mean. This is calculated from the sum of all values divided by their number. The limits of a mean chart are calculated slightly differently than those for the median chart. Finally, there is the mode. This is the most common value. As stated at the beginning, both a shift in the process location, this means a shift in the process mean, and an increasing spread can lead to product characteristics being manufactured that lie outside the permissible limits. As can be clearly seen here in the value curve, the spread in the first part is small. In the rear part, the spread is so much larger that 3 values are outside the permissible tolerance. A shift in the process mean, up or down, can also lead to characteristics that are out of specification. However, to not make the repetition too long, I would like to refer to the lesson on the trend, run or middle third at this point as additional signals that a process might be out of control. To recognize an out-of-control process, it is possible to monitor, for example, how the median value of the individual random samples changes and how the range of the same random samples changes. For this purpose, the control limits are selected in such a way that there is a 99.73% probability that the median value of a sample, or the range of a sample, is between these limits. With a probability of 99.73%, the control chart does not generate a signal. Or in other words, with a probability of 99.73%, there is no need to interfere in the process. Hence the term non-interference probability. On the left side, you can already see the formulas with which the control limits for the median chart and the range chart are calculated. Let's take a closer look at these next. The symbol for the median is an X with that wavy line above it. This symbol is called tilde. Therefore, one speaks of X tilde. So, if X tilde is the median of a single sample, then X tilde bar is the mean of the individual medians. Thus, X tilde bar is the process center line for the process. Similarly, R is the range of a single sample, and R bar is the mean of the ranges. The factors A tilde 2, D3 and D4 for calculating the control limits are taken from tables. These differ from other factors used to calculate the 95 or 99% limits. The median values and the range are initially unknown. If the control chart is to be created for an existing series production, samples from the current series must be taken to determine them. If it is a new process, a small number of parts must be produced and measured specifically to determine this data. This process is called pre-series. And it's such a pre-series that we look at in this chapter and use the data to calculate the average median and the mean of the ranges. So, the diameter of 50 parts was measured and the results entered in the table on the left. On the right side, the individual values have been entered into a control chart for individual values. Their frequency distribution can be seen in the adjacent histogram. In all these calculations, we assume that the values are normally distributed. The bell curve laid over the histogram should suffice for us here as purely visual proof of a normal distribution. The median was calculated for each individual sample and entered in the right-hand column. Thereafter, the average of the median values was calculated. This grand median can be found at the bottom. Its value is 60.102 mm. This is the process center line. The same was done next for the range. For each sample, the range was entered in the table, and at the end, the mean of the ranges was calculated. R bar is 0.066 mm. The y-axis of the control charts must be scaled in such a way that extreme values can also be displayed in them. For the median chart, the y-axis should therefore cover at least twice the range of the largest and smallest median found. For the range chart, the area covered by the y-scale should be at least twice the largest range found. So, with that, we have determined the two required parameters, process mean and range, from the pre-series. Both values, 60.102 and 0.066 mm, have been entered into the table and control charts. Both are a part of the further calculations which we will carry out in the next chapter. In this chapter, the control limits for the median chart and the range chart are calculated, both for a Six Sigma range. The only remaining unknowns are the factors A and D. These are next taken from tables that can be found in the relevant literature or on the internet. A section of such a table is reproduced here on the left. For a sample size of 5, as in our example, we take the value for A2 as 0.69. For such a small sample size, the lower control limit on the range chart does not apply. For this reason, values for D3 can only be found in the table from a sample size of 7. For the upper control limit of the range chart, the value for D4 is 2.144. All values have been transferred to the table in the middle. If we now insert the values into the formula for the upper control limit of the median chart, we will find that this is 60.148 mm. A value of 60.056 mm results for the lower control limit. And finally, the upper control limit of the range chart is 0.14 mm. As already mentioned, due to the very small sample size, the lower control limit does not exist here. The probability that a value exceeds the control limits is less than 0.27%. When such an unlikely event occurs, it is an indication that the process may be out of control. The cause must then be found and the process readjusted if necessary. Both the median chart and the range chart can show such an event independently of each other. That is because with the median chart, the changes in the process location are monitored, and with the range chart, changes in the process spread are monitored. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 4 most important key messages. The median chart monitors the centering of the distribution of data from the process. The range chart monitors the width of the distribution. The control limits are set in such a way that there is a 99.73% probability that no interference in the process is required. A value outside the control limits indicates an out-of-control process. A readjustment might be necessary. If you found this lesson helpful, please let me know and leave a comment. Thank you for that. Take care and see you next time. Bye.